Many years ago, Santa brought my kid an electric scooter. But Santa picked this up from my clearance aisle, which might explain why it never worked. Instead, it sat for years in a corner, waiting for that day in which I was going to look into it. Well, I guess that day is today. First thing I wanted to do was place a new battery. I see power, so this should work, right? Yet pressing the ignition button does absolutely nothing. Is it the motor? Well, that works. Is it the ignition switch? Nope, that's not it. Could it be the brake? That's not either. All that is left is the power module, which is nothing other than a relay with some transistors to engage it on and off. Looks like trash, to be honest, so let's just toss it. Wait! You can reuse those wires! Okay, now it's trash. For this project, I'm going to use the same board we used for the blower project, configured as an H-bridge to drive the motor as it is, but instead of going simple, I want to add some levels of complexity like multiple speed and an acceleration curve. Now, in all reality, the hardest part of this project was adding a throttle control to the handle. The solution was incredibly chintzy, but I had little to go on. I created this little cylinder which held a potentiometer, and then I had to use a coupler to be able to attach to that screw-like structure that you see. That's all the handling I was able to get from this 50K potentiometer. A little wiring management. This is an old technique I use a lot to create wires that are a little bit more constrained. And then a groove so that I could pass the wire through. And in here we're putting it all together, and now my handle has a potentiometer that I can use to control the motor speed. More wire management. We're ready. Alright, so before we take this for a spin, let me show you what's the final product. I have the scooter being driven by my H-bridge controlling the motor, and I have two control entities, the push button and the potentiometer. The potentiometer is for speed, and the push button controls whether the motor can be enabled or not. Now, I was going to use only the potentiometer, and in fact, as it is, the code determines when the motor is enabled or disabled with the potentiometer. However, the push button is a safety that goes on top of that because there was a little accident yesterday. This is an incredibly chintzy implementation of an acceleration handle, and I have a coupler here because it's the only way that I can get that dinky little potentiometer knob. And well, believe it or not, I was riding the thing, the coupler fell off, and I couldn't turn it off, so I had to like get off the bezel and just pick it up until I was able to shut everything off. So kind of dangerous, and that's why I decided, no, let's put a button, so that way if the button is pressed, then the potentiometer can control the speed. So what's going to happen is, if I had the potentiometer all the way off and I press the button, the motor doesn't move because obviously there is no speed command. But as I increase the potentiometer command, then the potentiometer controls the motor speed by changing the duty cycle command into the power stage. The button is basically what is going to say whether the potentiometer can control the speed. So if I release the button, as soon as that happens, the motor is disabled. Let me show you that. Now, once the potentiometer is at A position, there is going to be a command. However, the button decides whether that command can make it into the motor. So you can change the potentiometer all you want, and you can set it on a position, and then when you press the button, the motor is going to go to that. And when you release it, the motor is disabled immediately. That's for safety purposes. Now, the last thing that I wanted to mention is that there is a little bit of an acceleration, so I'm not changing the speed immediately. I'm not going from duty cycle X to duty cycle Y. There is actually a little bit of an acceleration where I change the duty cycle every 2 milliseconds or so. So when I press the button, even if I am at maximum speed, you're gonna see that it takes a while to get to that. That acceleration profile could have been anything. I could basically go into the firmware and change the acceleration to whatever I want. And in fact, a really complicated system could have a bunch of knobs for changing the acceleration profile on the fly. But all I have is a button and a potentiometer, so not a whole lot can be done other than what I'm doing right now with those two control surfaces. All right, so I think I'm ready to see how good this puppy can carry me now. One thing is that when I press the button again, I'm gonna brake because the duty cycle is smaller than the speed. So the effective voltage that I'm applying is smaller than the effective voltage of the generator. So that feels like a brake. So I'm braking, basically I have released the button and now I feel the braking until the duty cycle accelerates again. So, it is what it is. This is a fairly weak motor. Help it a little bit, pick up some speed. Well, YouTubers, I think we can call this project a paltry success. Why do I call it a paltry success? Well, a success because the scooter moved, something that it didn't do after it came out of the box brand new. So after many years of being stuck doing nothing, it finally moved. Paltry, however, because let's be honest, everything that I put in here is kind of worthless. I hate to say it, but what did I put in here? So I have an H-bridge. An H-bridge allows you to move the motor both in forward and reverse. You're not gonna do that with a scooter. Second, you have multiple speeds, 10 speeds. Well, turns out that for me to be able to ride this successfully, I had to be going at maximum speed anyway, otherwise it would become quite unstable. So at the end of the day, one speed is pretty much all you need. Third, the acceleration was actually kind of a hindrance. You had to wait for the motor to get there. Now that is something you can probably tune and make better, but at the end of the day, if you only have one speed, then you don't need acceleration, or probably you don't want acceleration, you just want to go at that speed immediately. So because of those things, I think all of this is just unnecessary stuff and actually kind of a hindrance. However, the real reason why I went through all of these hoops is because what I want to do is drive this motor, which is a 3-phase BLDC motor with Hall sensors meant for electric scooters. This is the real ticket. This is the real project that I wanted to get my hands dirty with. But for that, I need to learn a little bit about what are the pitfalls of building an electric scooter. So I was able to learn a lot from this. And now I'm going to be able to put all of those topics in practice. Because let me tell you, this is going to be the big leagues. This is going to be 20 volts, way stronger, way faster. I would rather have an accident on the brushed DC motor version than on the 3-phase BLDC motor version, which is going to be way stronger. All right? So that's all of this, all of the project for today. The 3-phase BLDC motor is going to have a different project. It's going to have to be a different day. So I want to thank you for tuning into my YouTube channel, and I'm going to see you on the next one. What am I doing? I'm supposed to live on my scooter.